So let's see. This is going way back. Chapter 3 won't be on this test, right? The probability section. Okay. So we start off in chapter 4. That's the general probability distribution chapter. And then it gets into binomial. So it's this discrete probability. So that's where you got stuff like this. Hopefully that looks familiar. And then I've got this stuff here. Huh? Yeah, this is the formula sheet. I remember now. I'm remembering the old book. This is chapter 4. Yeah. Blah, 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 blah. And then, so this is for. This is a really stupid way to teach it, but after you've taught it and you've learned it, when do I use these? Probably when I give you a table with x and p of x. Right? It's fascinating how many people try to use other formulas for that situation. These formulas are just like crying out, hey, use me if it gives you x and p of x. Okay, maybe. And then we get into binomial stuff. And of course, the binomial mean and standard deviation's the most beautiful mean and standard deviation formula yet. All right. That was 5. No, that's right. 5 is uniform distribution stuff. The only thing I'm going to ask you about uniform distribution is draw it and give me the height, and then I'm going to ask you some probability questions. I'm not going to ask you about the mean. I'm not going to ask you about that freaky ass why is there a 12 standard deviation. You had to do in the homework just so you know they exist. So just plug and chug. And then we get into chapter 6, which is almost the most important chapter in the book, is the z-score stuff. Translating into probabilities, right? So you can put down this here. That's all we got so far, really. You could even put down, does everybody see how these are the exact same formula? Using different symbols, who cares? This group I use this symbol, this group I use this symbol. It's the same formula, doesn't matter. You could put down this formula. That should look familiar. Okay, I like it. I like it. I like it a lot. And then we've got chapter 7. To be honest, the z-score formula never changes. Do you remember these problems when I give you a sample and then I ask you about the sample mean? So before you do this formula, you get the correct standard deviation, right? Yes, is that right? If I were you, I wouldn't even write down what I'm about to write down. It's just for a complete story here. That just looks so complicated. It's the same stupid thing, though, isn't it? Take my data point minus the middle divided by the spread. And if I take a sample and I ask about the sample mean, I need this spread instead of that spread. So they're really the same exact formula. It just looks more complicated. Okay. Maybe. Anything else that I forgot? Yeah, I love that. It's like the pilot coming back and saying, did I forget to check something? I don't think I forgot anything, but if you have a suggestion on another formula you want on there, feel free to throw that out. No? Okay. think that's everything. Yeah, I'm pretty sure that's everything. Okay, all right. Now that a few more people have stumbled in, anybody else need a copy of the practice test? Huh? You need practice test?
But not the correction.
Oh, there you go. All right, that explains that. I thought I was going crazy. That's normally the answer. Okay, now it's wide open. If anybody still has a suggestion for another formula up there, you can bring all your formula sheets with you if you want to confuse yourself. You can always just keep bringing all of them. I don't care. I'll just keep taking them from you and then giving them back. All right. So now it's wide open to whatever you want to focus on, whatever questions you got. You can sit there quietly and work on the practice test, and then I'll give you the answer key. You got quiz corrections to make possibly. Cool. So you got, I think we have 3 quizzes since the last test, and all those corrections are due Monday if you want to get full points back as much as you can. I love you guys so much. Yes? Test corrections, what about them? Test 1 corrections are still, they're still on time. Corrections are always due the day of the next test. So test 1 corrections, they're due Monday if you haven't turned them in yet. We didn't do chapter 8. That's for the next test. This test only goes up to 7. Central limit theorem. Chapter 8 is confidence intervals, so we're going to do that next test. And there's a ton of formulas in there. Well, 5. That's a slight ton. Huh? Yeah, I don't think so. You guys doing all right? You guys all right?
Can we do, or go over the practice test 4B?
4B? Okay. Everybody's got this here, right?
No, just 1 second.
So 4B. Oh, I see. Okay. I'm with you.
Okay.
All right. Okay. So this is 4B on the practice test about the standardized math test. Look at 4A number 1. And then look at 4B. Is there a common theme to the question in a way? 4A number 1, you figure out the percentage of students that would have greater than 302. Right? Is that cool? Probability is percentage is now area. Those are all the same thing. So if I know the percentage of students that scored greater than 302, and then I say, I got 2,000 students, how many of them scored greater than 302? You take that percentage of 2,000. So what'd you get for this one?
60%, or no, 0.27.
There you go. That was the z-score. So here, after you do some work, you should get 2743. And And there's a bonus question on the quiz. Here's the correct, I've got it here together. Here's the correct way to look at this. 27.43% of students scored more than 302. So if I have a group of 2,000 students, how many will you expect to score more than 302? That percentage of them. Throw the old calculator. I love that question because you so often you get so used to this being the end of this question, and I'm like, no, you can do more shit with that. Especially if you understand what it is that's telling you. Okay, maybe. A little hopeful Tai Chi. Okay. Where is it on the test that I have to do that sigma divided by square root of n on the practice test? If anybody's done that whole thing.
Well, I used that on that one, but obviously I was wrong.
Yeah, no. Why? Now watch. All right, this is exactly why I try to be specific many, many times. When do I use this? Two things have to happen for me to do this. Two things have to happen. I have to take a what does n represent? What does n mean? What is n? Sample size. So when do I do this? When I take a sample and I ask a question about the sample mean. So if I took a sample of 80 people and I'm like, what's the probability that the sample mean of those 80 people height is more than 6 foot tall, then I have to do that. On 4B, did I take a sample? Yes, I did. 2,000 students are selected.
Yeah.
Did I ask a question about the sample mean? No. Nope. So I wouldn't do that kind of thing.
So what does it ultimately give you?
This formula?
Yeah.
All right, so let's see if anybody, this is always a scary time for teacher. Did anybody listen to me at all? What does that symbol by itself really mean? Be very specific. Standard deviation for what within a sample? Standard deviation for the, this is like individuals. So if I want to know the probability that one person's height is more than 6 foot tall, I would use that because that's how spread out individuals are from the mean. What does this do? When I do this, what do I create? The spread for not individuals anymore, but the spread of what? I love you guys. I've said this so many times, and I'm going to cry a little bit later. So this by itself is the spread of individual data points from the mean. Right? This is the spread of sample means of samples of size n from the mean. So when do I use this? When I'm asking a question about an individual. When do I use this? When I'm asking a question about sample mean of a group of people. That's it. And what's going to come up, just to kind of let you know right now, even if I have S, I still have to do this if I ask a question about a group, because S is the standard deviation of individuals in a sample. So if I take a group of things and I ask a question about the group average, I still have to make the spread for a group of n things. So all this formula does is convert it from individual spread to group spread. Right? And that's why I said, when do I do this? When I take a sample and ask a question about the sample mean, the group mean. Maybe. I love you guys so much.
at the bottom, sample means like,
Samples of size n.
okay.
Yeah. Okay, maybe. Some of you guys look so angry. I'm sorry. You're thinking, what have I chosen in my life so that I came into this class? I'm sorry. Question your life choices always. All right. Anything else at all about anything? Even something I already said, if it still doesn't make sense, today's the day I'm not going to go right past you. Yeah.
For the quiz that we just took
Yeah.
can you go over question 1C, please?
Let me see. Here we go. Oh, all right. What will this symbol always represent? This is this one, right? P21? What will that symbol always mean? Percentile. 21st percentile. And I'm dealing with the normal distribution in that problem, right? So where would that go on the picture? Yeah, good. Down here. Why? Because it's only supposed to have 21% in the tail. Now this is really kind of evil. And again, I warned you about this. It's not the fault of the things. It's not math people trying to be mean. It's just the way shit is. 0.21 looks like a z-score. Right? But we know it isn't. We're the humans. We're supposed to be able to consider what the shit something is. This is not a z-score. It's an area. I'm asking for the z-score. Right? In fact, on that one, I think it was just a z-score. Yeah. For one ABC, they're all z stuff. So a few of you guys lost some points because you didn't get the right number. Some of you guys got negative 0.8. And if you look in there again, that's closer to 0.21. So I don't know, if you look up 0.21, what's the closest you can get to it? If you look up 0.21, why do I look in here? Because it's not a z-score, it's an area. Areas are in here. The closest I get to 0.21 is 2090. The closest I get to 0.21 is 2090. And that's a negative 0.81 z-score. And the crowd goes, all right.
Crowd goes.
Exactly. It's all right. I don't blame you. So I try to talk about how what we're doing in this class can immediately be used in real life. The unfortunate thing for us is this is stats 1. So it's very much a nuts and bolts, collect the tools kind of class. We do several problems that are very real life problems. But this really is focused on just you need to learn all the processes that are used. And then if you went further, you'd start really applying them. Maybe. So, all right. Back at the school I worked at on the East Coast, I was the assistant to the director of research and planning. That was one of my many hats that they put on my head and didn't give me a raise. And I was tasked with, there was a year where student success just went crazy good, and then it kind of went back to normal. So they wanted me to analyze what it was about that year. Did we do something different? Did students do something? So what I did was, I identified all these categories and I had all this information. So I calculated z-scores for the students of that year compared to all students over the past, I think it was 50 years. And if the z-score came out to be like 2.8, well holy shit, that's really far off from normal. What was that all about? So it turned out that they were more involved in student organizations and stuff for some random reason. we looked back and said, did we mark it better? No, they just came in more involved. And the more involved the student is, the better they do. So that's one thing. There were several other things that were kind of like unusual. Do you guys see what I'm saying? That's something you could do. If I gave you the data, you could do that immediately, and then it would have immediate practical use. Was there something we did different and we stopped doing? Let's go do that shit again because it seemed to help. Yeah.
How do you know it's not just that students were more academically inclined or also...
That's another factor we looked at. We looked at incoming scores, incoming GPAs. Did it change? Were they coming from different regions than normal? All kinds of stuff. Was the age different? Trust me, dude. Huh? Yes. So one thing is, if you watch Mythbusters, I really do love Mythbusters, although sometimes they don't really. Anyway, they do a decent job of explaining stuff like controlling variables, right? So if you want to test your drug out, or you want to analyze why some group of people is doing better at something, you have to take away. Maybe they all happen to be younger, and that's why they're all healthier, or maybe they all whatever. They don't have access to corn syrup, high fructose corn syrup. So, right, that's one of the main killers of us nowadays. All right, enough of that. Sorry, you guys look even more bored now than before. Okay. So, anything we want to go to next? Anything from the practice test, quiz, general questions about why the shit does this do this? Anything?
For the quiz that we just took, QC, I know that volcano.
Oh, one thing about that, some people got the wrong z-score again. So that's the one that's related to this one? Some people I said top 8%, and they put the 8% down here. Well, that's not making sense. Top 8%, right? That's the one you're talking about, right?
Yeah.
So how do I figure out the grade that puts somebody here? I first have to figure out the z-score. I like it. So what's this area?
0.92.
Beautiful. And what z-score do you get?
I did 0.92, and then I minus it from 1, I think.
And then you got that again? And you go in circles? You need the z-score for this. So you got to look up 0.92 in the body of the z-score chart. That's an area. And figure out what the actual z-score is. Just like we did with the 21% just a minute ago. You got to look that bad boy up in the chart and get what the z-score is going to be. Is it going to be positive or negative z-score? Positive. It's above the mean, so it's going to be positive z-score. Is that cool? So the closest I can get to 0.92. What's as close as you can get to 0.92? Yeah, 1.41. I like it. It's 7 away, and the other one's 8 away. And then what do you do with that shit? Well, if you got the z-score and you want a raw score, in this case a grade, you use that backwards formula. Okay. Maybe.
I use 0.92 as a z-score.
Oh shit. That'll do it. It looks like a z-score. It's so evil. But you have to tell yourself and immediately write it in the right place so you don't sort of forget that that's not a z-score. So there are ways you can be nice to yourself in a problem. I'm the one that's supposed to be mean to you. You should be nice to yourself. An advanced degree in meanness to students. Some of you guys are like, that's not even a joke, man. It's true. Say again? Double quiz was like 2 quizzes. Yeah, in the average, I counted it. The grade you made on that, I counted it twice. So it counts twice as much as a regular quiz. Yeah. So corrections to that are twice as important in a way to your GPA. Now, you do things to directly make a higher grade. But the more important thing behind that is you do things to understand the material better. We all know this. As a student, you have so much pressure to make grades, you just focus on what's going to make my grade higher. When really, if you just would focus on what's going to make me understand this shit better, your grade will naturally get higher. That's enough of that. Sorry. It's a little PSA from Jeff. The more you know. So a huge part of my job is trying to trick you to do the things that will help you. Yes? Oh my God. What is it? Which one? Oh, yeah, if you made a mistake at a certain step, just kind of pick it up there. Yeah. You stretch it. Okay.
Do you want it on a separate piece of paper?
On a quiz, you could do it on the back. You could even do it next to the problem if you make it really clear what the correction is. Don't erase the original work.
How about the test?
Test, I normally want another sheet of paper because it's just, there's too much going on. Yeah. Turn in the original with the corrections. Maybe I should give you the answer key. I don't know if that would spur some things. I know some of you guys have done. Now again, I'm going to say this again. If you haven't tried the practice test out yourself, maybe don't even look at this. Because, again, you will do this. Yep. That's what I would do. Yep. And build all this false confidence. You take the test, you suck at it, and you get angry at me. No, don't do that shit. So, well, I don't care personally. You can be angry at me if you want to.
Their loss.
Yeah, I love it when I give a test or something, especially a final. Oh my God, I see people that I have no idea who they are. I'm like, who are you? Oh yeah, you're in my class. Oh shit, good to see you again. Such a great day. I'm like, oh, everybody.
I had one of those nobody's face the script.
Huh?
Face the final.
Oh yeah, I've had people that really shouldn't have been in the class in the first place. You know what I mean? They should have been in a higher class. And they'll ace it finally. Who cares? It's great. What's wrong with that? If you want to waste the semester, great. Let me see. Yeah, I think I got it. I didn't finish 6E for some reason, but just so you know, I am not, so again, this is kind of silly on my part, but the reason I put this problem on the practice test, 6, I am not going to ask you questions about the mean and standard deviation of a uniform distribution. So then why the hell, Jeff, did you put this problem on this practice test? Because of E, I really wanted you to realize I don't care where that standard deviation comes from. If I take a sample, see 6E, I take a sample of size 43, I have to take whatever the standard deviation was and divide it by square root of 43 now. That idea is independent of where the shit that standard deviation came from. Take a sample and I ask about the sample mean, I change the standard deviation. So I almost don't care about the rest of that problem. It's just I have to change the standard deviation to be able to do that, just like always. Oh. Oh, cool. Yeah. Thank you.
For quiz corrections, do we staple it on the front or the back?
Oh, front's fine.
Okay.
Yeah, especially because you already got it here.
Alright.